Hi everyone, in this video we are going to discuss the fifth module. It is about the fuses. Okay, first you have to see what it means the fuse. You know that usually you have seen fuse in your home. It is the simplest form. It is a very small piece, thin metal wire or it may be strip connected in between two terminals mounted on an insulated base and forms the weakest link in series with the circuit. So we call it is a fuse. Very cheap, simple and oldest protective device. So the full details theory part they have given, no need to explain same thing again. I have to read same concept here only. Don't I'm not going to waste your time because very short time we have to complete this module and also I have to take third internal, lab internal and project phase 1. So theory part I hope you read and you can understand easily. Fifth module is theory, very easy. Simple form is there. Okay. So fuse is a protective device used for protecting cables and electrical equipment against overloads and or short circuits. It breaks the circuit by fusing, means melting the fuse wire. The fuse element or fuse wire, when the current flowing in the circuit exceeds a certain predetermined value, okay, it melts and fuse it start work. Okay, so it breaks the circuit by melting the fusing element. Okay, the term fuse in general refers to all parts of the device. So we have to refer here some important definition regarding the fuse. What is the fuse? What is the fuse element? Okay, it is the part of the fuse which melts when current flowing in the circuit exceeds a predetermined value and thus it breaks the circuit. Okay, so this is the fuse element. Then what about the rated current? A rated current means the current of a fuse it can carry indefinitely without fusing. Okay, that is what rated current at which it melts. Up to that current that we call as a rated current. What it is the minimum fusing current? Minimum fusing current is the RMS value at which fuse element will melt. Minimum value. Okay, rated means highest and minimum means minimum value at which fusing element starts melts. Okay, I is equal to kd raised to 3 by 2 here. Okay, where what is the k value here? See here, the minimum fusing current depends upon the various factors such as material length, shape, area of cross section of fuse element, the location, the terminals, okay, the type of enclosures employed. So the minimum fusing current for a standard fuse wire will be less than the product of minimum fusing current for one strand and the current of strands. Current strands means cables group, okay, and that is the bundle of the cables. For example, the typical values of fusing current here for typical values of fusing current for standard fuse wires having 2, 3, 4 up to 7. Okay, means 2, 3, 4 means a bundle is 2 cables, 3 cables, 4 cables means we call it as strands. The approximate value of minimum fusing current is Ki is equal to Kd raised to 3 by 2. This is your approximate value, that is fusing current. Okay, see in the table they have mentioned the value of K and D in centimeter. Okay, so next, what about the fusing factor? Fusing factor is the ratio of minimum fusing current divided by rated current. Prospective current. Prospective current means what? See here, the figure shows the about the prospective current, that is here IP value. Where is the IP value here? Here prospective current, that is peak value. Here the first major loop of the fault current, that is first major loop of the current, first major loop, highest loop. The prospective current shown here dotted lines. It is the current which would have flown in the circuit if fuse had been absent. Fuse had been absent, that is it had been replaced by a link of negligible resistance. It is measured in terms of RMS value of AC component of fault current in the first major loop. This is we called as IP, that is peak value of prospective current. This is prospective current. Is it clear? Then what about the cutoff current? Cutoff current is denoted by IC, cutoff current. The current at which fuse element melts is called cutoff current. Okay, and is measured as an instantaneous value, so that RMS value to be less than the cutoff current. Since the fault current normally having a large first loop generates sufficient heat energy, the fuse element melts well before the peak of prospective current is reached. Okay, this is what I see. Next, pre-arcing time. See here, the pre-arcing time means what? Pre-arcing time or melting time. Okay, the time taken from the instant of the commencement of the current which causes the cutoff to the instant of cutoff and arc initiation here. OA. Okay, and this is OA is the pre-arcing time. What is the pre-arcing time? It is the time, okay, from the instant of commencement of the current from O, okay, which causes the cutoff, which causes the here IC cutoff, which causes the cutoff. Okay, so this instant from O to A we called as the what? Pre-arcing time or melting time. What about arcing time here? TA, okay, that is arcing time TA. This is the time taken from the instant of cutoff. Okay, that is arc initiation here, IC, from cutoff to the instant of arc being extinguished, or the current finally becoming zero. Arc extinguished means when arc comes to zero. Arc is fully extinguished, that time from the arcing time to extinguished time, that is zero current time. Okay, this AB is called as what? Arcing time. Okay, then total operating time. What is the total operating time here? Total operating time is equal to TPA plus TA, that is O to B. Next, rupturing capacity or breaking capacity. Okay, rupturing capacity or breaking capacity means it is the MUA rating of fuse corresponding to the largest prospective current which the fuse is capable of breaking at the system voltage. This is what rupturing capacity. Okay. Here these are the what definition just now I have seen. Then fuse characteristics. See the fuse characteristics. Next, types of fuses. Okay. See, type of fuse is rewirable type. This type of fuse is rewirable. Okay. The blown out fuse element can be replaced by a new one. Rewirable. Okay. ಯಾವುದು ಫ್ಯೂಸ್ ಮೆಲ್ಟ್ ಆಗಿ ಬ್ಲೋ ಔಟ್ ಆಗಿರ್ತದಲ್ಲ ಅದನ್ನ ತೆಗೆದ ಇನ್ನೊಂದು ಹೊಸದ ಹಾಕೋದು ನ್ಯೂ ಒನ್. The fuse element can be either open or semi-enclosed. Therefore, here again there are two types: open type and semi-enclosed type. The total enclosed or second type is total enclosed or cartridge fuse. The fuse element of this type of fuse is enclosed in a totally enclosed container and it is provided with metal contact on both sides. And again here two types: D type cartridge fuse, link type cartridge fuse. We call it is a link type. We call it is a HRC cartridge. HRC fuse. Very important this one. Okay, HRC fuse. Next, in the open fuse, in an open fuse here, see open fuse. It is a thin piece of wire of a thin lead or copper inserted directly in a circuit. It is simplest and cheapest form of protection, but due to the fire hazard and unreliable operation caused by oxidation, it is seldom used any longer. Okay. So next is what is semi-enclosed. Next is semi-enclosed rewirable fuse. Okay, so this is your diagram of that. See, fuse carrier is there. Top one is fuse carrier, middle is fuse base is there, and here terminal. This is porcelain. Okay, porcelain metal, porcelain base. See here, fuse carrier contacts are there. Fuse element here middle. Okay, that is fuse carrier. It carries the fuse element and contacts here. And here is fuse base. Okay, contact terminals are there. So what happened here? It shows the various components of the this fuse. The fuse wire is fitted here. The fuse wire is fitted on a porcelain carrier, which is fitted in the porcelain base. Okay. Whenever the fuse wire blows up due to the overload or short circuit, the fuse carrier can be pulled out. The new wire can be replaced and service can be restored. The fuse wire may be of lead, thin copper, or any alloy of thin lead. The fuse wire should be replaced by a wire or any correct size or specifications to that. Otherwise, it may prove dangerous with the possibility of the equipment burning out. So here, because of the simplicity and low cost, this type of fuse is extensively used as protected device on low voltage circuits. But fuse wire is exposed to the atmosphere here. Therefore, it is affected by the ambient temperature. As the fuse is affected by the ambient condition, its time current characteristics is not uniform and gets destroyed with time, resulting in unreliable operation and lack of discrimination. Therefore, these fuses are mainly used for domestic purpose lighting loads for all important and costly equipment operating comparatively lower voltages up to the 33 kV. Cartridge fuses are used because they provide more reliable protection. Okay, see here rewirable fuses disadvantages. See disadvantage unreliable operation, lack of discrimination, and time lag. Okay, and risk of external flame or fire.